You remember this series? Yeah, it's definitely been a while. I haven't forgot. I've definitely seen plenty of your guys' comments. There's a couple of them on my tutorial series. And because of that, I'm picking this thing back up where we left off. And the hope is I have much better editing skills. And I make things a lot more detailed and a lot better to notice and, you know, keep track and think about. Because I've also seen some comments saying they've had issues and that I'm going too fast. So I'm going to slow down and try and explain as much as I possibly can for you people. Okay? And if you think the video is too slow, remember you can always speed it up in the YouTube settings, or you can slow it down in the YouTube settings if it's too fast. Or you can pause the video at certain points and just copy and paste the code I have on my screen. Anyways, let's start the video. Today, we're going to be doing level design. I've seen that a couple of you have been making a game, and, well, I guess if there's a game, there's a level. And since I've already made this thing a little bit physics-based, here's what we're going to do. We're just going to make a simple level with a base area so that the player doesn't fall out into the void, and make sure that base area also is like surrounded by a box. So the box covers the whole screen, and this prevents the player from going out of the screen. And then, along with that, we'll have small little obstacles within the level, upon which we could then set to triggers to trigger this event or this event. And once we finally get far enough within the series, we can then add sprites and make the thing look nice besides this. But up first, we're just going to make our little basic level. And to do that, first up, here's what we're going to do. Just start this for a quick reference and hit full screen. Because this is now how we're going to be having our game now, like this. So, to ensure that at all times our window is full screened, let's go into our code. And what we're going to need to do is we're going to have to, in each tick, set application dot current dot window main window dot window state equals window state dot maximized. Always make sure to have your semicolon. So now when you start this, you'll get this. Window state dot maximized. So when you start it, you'll get this. A completely full screen application that still functions as normal. There is, by the way, a reason on why I did not want to continue this that well, and just go overall, is mainly because of the fact that C# is not the best language to make any assortment of game engine or game in, but just because, let's do it. So now you see your full screen application. What we're going to have to do is, first up, we're going to have to grab the edge right here and scale it up to our full screen. Your computer may be a wee bit slower for a little bit. But with enough tinkering, and probably with not even adjustment in the first place, you'll be able to find out where the top, which this will probably be the easiest part, is the top and the left. So now let's just quickly set the width to be, 1000. Just in case. and you can see that this is about half my screen. So if I double this, this should be fine. You can set canvas left to be 0, so it's flush with the left side of the screen. So now at 2000, we have a permanent upper wall that cannot be moved, as you can see. Another quick adjustment I'd like to make to our code is pretty simple, and it's, never mind, it's already there. We can duplicate this rectangle, and we could just change the height to be our giant number. Make sure you get rid of the width as well. This is going to be a giant rectangle if you don't. With that, this happens. We're now settled down right here. So now we got the left side of our box. But don't forget something. You're going to need your tag. What do you want, cutie? Does it appear this thing might have bugged out for a quick second? There we go. If a component is unreachable, the code will not tell you. Keep that in mind. It will just break. That's it. I have my little kitty cat here. Now, if you want to keep things a little bit nicer, because if you want to actually have a lot of stuff in your level, you're going to have to shrink down your player and change a couple things. What we're actually going to do is we're going to make this your standard platformer game. So, not only will we have this, right, but we're now going to have to subtract gravity instead. Which, well, even though that's the actual constant for gravity is 9.8 meters per second, you're going to have to tinker with this to where you're going to like it. Where we're usually going to start off with a number around 2. Which, if you, as you could already see, that was a little fast. So we could try something about 0.3, and that seems more like it. Cutie cat. Sorry, I have my cat here now. No, 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 do not. No, please exit my room. I'm sorry. I love you. But please do not get in the way of recording. But if you want terminal velocity still, you are going to have to keep this line beforehand. So, what 2 lines you're going to need to add at the moment are a simple subtraction problem, and you're going to have to order it like this. Cutie, could you please get off my lap? No. Love you, but not at the moment. I mean, I do love you, but yeah. You're going to want to multiply this by your terminal velocity, which we're just going to keep it pretty simple at like 0.8 or 0.9. But for now, let's just keep this the same as friction. So your max speed is always the same as how fast left and right you can go, which does not exactly appear to be the best idea. As you can tell, get rid of that line. So the only line you're going to need is going to be just a simple subtraction problem that replaces your friction problem. Now you have this. Next up, get rid of your down key pressed if statement. You don't need it anymore. So come on up here to where you define all those little variables, and you can now completely remove when down key pressed variable. Just like that. Make sure to move it from everywhere. And so now you can no longer adjust your downward speed. But here's our next issue. We need to add a ground. We still haven't done that yet. So what you need to do for that is not exactly the best thing. This is definitely tedious, but what you're going to have to do is, this does rely on how big your screen is, but you're going to have to just go back and forth between your main screen and stuff and just keep tinkering with it until it fits. Also, this is much bigger than my screen is, so we can just slap an end on that. You could also try to see where this ends, and as you can see, my screen is just 1000 pixels long. So with that, we can align this on the side just like that, slightly down, and maybe half over there like that. And since we know the actual width, I think remember, just keep tinkering with this thing until it's all good. And with that, I have the dimensions of our screen, and I'll put them in a list off on the side of the screen so that you can see what they are, and you don't have to manually enter these in by yourself, as long as your screen is like the same dimensions as mine. But this is about all we're going to need for the moment. But your character can fly, which that is not good at all. Also, if you're using the tactic like me, where you just hit Control-C, Control-V, and duplicate something, make sure to get rid of these horizontal alignment things and these vertical alignment things, just to be careful. And at the same time, make sure that canvas left and top both exist. As if collision might not be working, and the tag does exist on the UI element, then the issue may lie in the fact that it can't actually find the correct position. So do that first. But now let's address your flying player problem now. This guy can go to the sky just if he felt like it, as you can see. And also almost surpass the entire thing if he needed to. So what we have to do with this, we now have to add a new check. We're going to call this one has jumped. Add this to our Boolean variable declaration. The has jumped Boolean variable. And now, here's what we're going to have to do. Is now in here, in our game tick section, is we're going to see if up key is pressed. And then we're also going to check if jumped, if has jumped. And well, if you have jumped, then don't do anything, at least. So put an exclamation point before the variable, and this inverts the statement. So we're saying if the player has not jumped, then we can say speed y is now equal to a set number. For now, we're going to just call this one 5. But the issue may be that even though we've never jumped, once we do, we can't jump again. But also, beforehand, make sure to say has jumped is true, as you don't want to just keep jumping. Now here's the thing. Remember our collision thing right here? Yeah. Remember how we can do the Y statement separate from the X statement? Well, here's where it's useful. We can then ask, right here, if canvas dot get top player of the player, its top position relative to the top, is greater than the canvas's get top of our object X, then what we're going to have to do is set has jumped to false. This will then allow us to jump again. As you can... I forgot about that. Yes, make sure this is less than. And so now we can jump. Ta-da. And this even works if you hold down the button. But you may be asking me, why is this game engine starting to lag so much? Well, as I said, C# is not exactly the best language to be coding any assortment of game engine in. If you guys want me to, I can do Unity game engine development as well, which is why I didn't want to do this one as much. But to help you guys, first up, 20 is too big of a number for this. As you can see, our character can now jump, but this has already solved our issue with this. You cannot jump when you hit a wall. You can't wall jump like that. But that's already another issue, is if you do want it to wall jump, you can't. You'd have to change a couple things in the physics engine. Right here. So what's up next? Something not exactly simple is optimization. If you want this thing to run smoothly, know that our 4 objects take up space on your computer, and this space on your computer has to, not last forever. So essentially what we need to do is, instead of looping through each of these, every single one of them on your screen, we're going to get the things on the screen first. Game screen dot get tag is first you're going to check for this. Then, up next, we're going to want to check if the distance, or at least the absolute value of our distance from canvas dot get left of our player minus our canvas dot get left of x dot, well, yeah, of just x. If the entire thing is less than, we're going to say, I don't know, 50. This will not start calculating until the player has gotten close enough to the object on either axis. But now you're going to say, we haven't calculated the y either, which is why, well, we're now going to calculate the y as well. Copy and paste that. Let's switch the get left to the get top function, and that's about it. If you run this, things should be slightly smoother. As you can see, we're not calculating any assortment of physics on any of these three objects around me, except for the one right below me. But then the moment we get to a corner, we are calculating physics on both of these objects. Which, I now take a look at this and I realize, you know, it would probably be a little bit better if we just didn't have this if check in the first place. Hey, well, would you look at that? It's still perfectly smooth. If you want to know why, by the way, it is lagging like this, if you take a look at your little process memory, you may notice... oh, I forgot about that. You may notice an interesting thing that revolves around the fact that the set C# has a trash can, which sounds kind of dumb, but if you want to know what it means that unused pieces of memory will get thrown away in order to increase, you know, efficiency, so that your computer doesn't have a memory leak, and suddenly all of your memory is just gone, and then your computer crashes. That is what it's meant to do, is prevent that from happening. But this is at the cost of the language's performance, because not only is it always having to check the status of each variable and when was it last used, how was it used, and why was it used, it also has to run all the code. Which we could probably talk about pointers in another video, but for now, we're just going to stick to game engine design. So now, finally, we can do simple level design. With our very small boxes like this, we can then hop right into here and make our level. And if you want to copy mine, go on ahead, but for now, I'm just going to make a very simple level. Pretty simple. All I did was just hit copy and paste, and now we have all this as our quick little level. And now if we hit start, we have a little level that we can just pop around in. But you may notice that, as I just stated, the language is starting to lag a little bit more, maybe once every half a second or so, maybe once a second. That's the trash can trying to get rid of all unnecessary variables. But there's another issue. I just now figured this out looking at this. And it's that, oh no, we can jump mid-air as long as we still have not jumped yet, allowing us to essentially jump across larger gaps than originally intended. As you can see, I can make it all the way from that platform to the other wall, which that is not good. To fix this issue, all we need to check is to make sure that our Y speed is not less than 0. And if our speed Y is less than 0 after the collision check, then we can remove the has jumped, but beforehand we're going to need a new variable. So come on up here to your variable declaration area, and now we're going to need a new type. Type in private int for integer. We're going to call this jump timer, which sounds kind of dumb at first, but you'll see what it's used for here in a second. So scroll back down to your collision section, where you're defining collision after your movement. And now we're going to say if speed Y is less than 0 and we don't need the and. If speed Y is less than 0, then that means we're falling, which is not good. We're also going to want to come up here and we're going to go to this and section. And then we're going to put the jump timer is less than, well, is more or less greater than 5. This will give us 5 frames to jump off. This will be useful for in later tutorials when we add slopes, which cannot be calculated here yet. I've already tried. Kinda sad. Yeah, I know. This is only because of the fact that Rex can handle your X and Y position and height. It cannot handle the very weird and complicated things that revolve around the fact of rotation. And rotation is on a whole different scale. I guess you could say literally. We're going to say in here, if our speed Y is less than 0, then we're going to take our jump timer. So jump timer, we're just going to add 1. All right? And then inside of here, we're going to say if jump timer is greater than, I'd say 10, then what you're going to do is set has jumped to true. This will now prevent our player from jumping if they're falling. As you can see right there, I just failed to jump right there. But now there's a new issue. Your timer's never reset, and so you don't have that nice little feeling where you can jump just a wee bit off the edge. So come down here and slap an else on here, and all you gotta do is set jump timer to 0. Do not follow the intelligence of this. And so with that, you should be able to jump off just a couple frames, but not too terribly far. As you can see, I couldn't jump there, but I will notice that 10 frames is a little bit much. A lot of game engine design and just straight up game design is tinkering with until you think it's good. So we can check here on our jump timer, and we're going to set that to 5 instead. There you go. Pretty perfect in my opinion. Or at least it's good enough for my house. But now, we straight up can't do that delayed jump. Just kidding, we can. It's just kind of like you need to be really specific when this happens, as you can see. And now our player can jump around levels. Pretty neat, huh? Now, I will say this. If you do get lost, please tell me in the comments. You can contact me in Discord. I have a Discord server where you can ask for help. You can contact me directly with hashtag... you can contact me directly. Friendly Neighborhood Programmer. Capital F. Just make sure it's a capital F. So, capital F. Friendly Neighborhood Programmer. Hashtag 8054. You can contact me there, and you can ask me for help. So yeah. You can see the game engine is slowly starting to come together. Now, next time, we're going to do some extreme optimization because we are going to make this a scrolling platformer, which I'll tell you right now, that is where the fun begins. And just on a pretty good note, I will see you within the next episode of the WPF tutorial, and I hope that you have a good rest of your day. Adios.